Right now, water covers 70% of the planet you live on. In the next 90 seconds, imagine all of it gone, not melted, not moved, gone. What would actually happen to you, to the air you breathe, to the ground beneath your feet? Most people picture a dried-up ocean as a giant empty bowl, cracked mud. Maybe some fish skeletons scattered across the bottom. That image is almost completely wrong. The real version is stranger, faster, and far more violent than anything you've imagined. Let's start with what the ocean actually does for you every single day without you noticing. You've probably never thanked it. Most people haven't. The ocean isn't just water, it's the planet's thermostat. It absorbs roughly 90% of the excess heat trapped by greenhouse gases, according to research compiled by climate scientists tracking global energy budgets. It also produces more oxygen than every rainforest on Earth combined. Marine biologist Sally Kishom, who discovered the tiny ocean bacterium Prochlorococcus, found that this single organism alone generates an estimated 20% of the oxygen in the atmosphere you're breathing right now. One microscopic organism, 20%, let that sit for a second. So what happens in hour one if the ocean simply vanished? The water wouldn't just disappear quietly. It would evaporate almost instantly into the atmosphere because there'd be nothing holding it down anymore, no basin, no gravity well of liquid mass keeping it stable. The sky would fill with more water vapor than it has ever held in human history. And water vapor, ironically, is a greenhouse gas, a powerful one. Within days, the atmosphere would become a pressure cooker. Storms wouldn't form the way you know them. They'd form the way they did billions of years ago when Earth's early atmosphere was still deciding what kind of planet it wanted to be. Rain wouldn't fall gently. It would fall as walls of water because there'd be so much moisture with nowhere stable to condense. Does that sound familiar? It should. Geologists have already found proof this kind of catastrophe happened before, just on a smaller scale. About 5.96 million years ago, the Mediterranean Sea nearly dried up completely. Geologist Kenneth H. Sue, working with a team drilling deep-sea cores in the 1970s, discovered thick layers of salt beneath the Mediterranean seafloor, sometimes over a mile thick. His research revealed that tectonic shifts sealed off the connection to the Atlantic Ocean at the Strait of Gibraltar. Without new water flowing in, evaporation won. The Mediterranean basin turned into a scorched, salt-crusted desert nearly 3 kilometers below the level of the surrounding ocean. Scientists now call this event the Messinian salinity crisis. It lasted for hundreds of thousands of years, and it left behind evidence so extreme that when researchers first found the salt layers, some of them didn't believe what they were looking at. Now scale that event up, not one sea, every ocean on Earth. The salt left behind wouldn't just sit there quietly either. Oceans hold about 3.5% salt by weight. If all that water disappeared and left the salt behind, you'd be looking at a layer of solid salt coating the ocean floor, in places hundreds of meters deep. Entire mountain ranges of pure sodium chloride, stretching farther than any desert you've ever seen. Wind would pick it up, it would blow across continents. Every breath, everywhere on Earth would carry a fine dust of ocean salt. Have you ever wondered what a lungful of salt dust feels like? You wouldn't want to find out. But the real collapse wouldn't come from salt, it would come from what's missing. Oceanographer Sylvia Earle spent over 7,000 hours underwater across her career, and she often said something that sounds simple until you really sit with it: no ocean, no us. Phytoplankton, the microscopic plant-like organisms drifting near the ocean's surface, are responsible for producing somewhere between 50 and 80% of Earth's oxygen, depending on the study you look at. Not the Amazon, not the world's forests combined. The ocean, quietly, invisibly doing the heaviest lifting on the entire planet. Take away the ocean and you take away most of the machinery keeping oxygen levels stable. It wouldn't happen instantly. But within a few generations, oxygen concentration in the atmosphere would begin a slow, irreversible decline. Every land animal, every human lung, every fire that has ever burned depends on a level of atmospheric oxygen the ocean helped set in the first place. There's another system quietly running underneath all of this, one most people have never heard of, and its collapse might be the fastest kill switch of all. It's called the thermohaline circulation, sometimes nicknamed the Great Ocean Conveyor Belt. Geochemist Wallace Broecker, one of the scientists who popularized the term, described it as a slow-moving loop of water that carries heat from the equator toward the poles, then sinks and travels back along the ocean floor. This single system regulates the climate of entire continents. Without it, northern Europe alone would likely be several degrees colder, closer to the climate of Canada at similar latitudes, according to brokers' own modeling on abrupt climate shifts. Remove the ocean and you don't just remove water, you remove the delivery system that keeps half the planet's climate from swinging into chaos. So picture the timeline now, laid out plainly. Hour 1, mass evaporation, atmospheric pressure spikes, unprecedented storms begin forming. Week 1, rainfall patterns become violent and unpredictable, salt dust starts spreading globally. Month 1, coastal ecosystems, which support an estimated 40% of the world's human population living within 100 kilometers of a coastline, begin collapsing entirely. Year 1, fisheries, a primary protein source for over 3 billion people according to United Nations ocean assessments, are gone. Decade 1, oxygen production drops measurably. Climate systems that depended on ocean currents destabilize completely. Century 1, the version of Earth you grew up on no longer exists in any recognizable form. Does any part of that timeline feel exaggerated? It shouldn't. Every single stage is built on documented science, just applied to a scenario no one has ever had to survive. Here's the part that might be hardest to accept. You don't think about the ocean most days. It's just there, distant blue background scenery in a vacation photo. But it's running life support for the entire planet in real time right now while you read this sentence. The ocean isn't separate from your life, it's underneath every part of it. The rain that fills your reservoirs traces back to it. The oxygen in your next breath was very likely made by something floating in it. The stable seasons you've never had to question exist because of a current system moving heat around a planet you'll never fully see. Paleontologist Peter Ward, who has spent decades studying mass extinction events in Earth's history, has pointed out that nearly every one of the 5 major extinctions in the fossil record involved a disruption to ocean chemistry or ocean circulation. Not asteroid impacts alone, not volcanic eruptions alone. The ocean's response to those events was often what finished the job. Life on land rarely dies from the first blow. It dies from what happens to the water afterward. So no, the ocean's drying up isn't really about empty seabeds and cracked mud. That was never the real threat. The real threat is what disappears with the water: the oxygen factory, the climate regulator, the food source for billions, the thermostat holding this entire planet in the narrow, fragile range that allows anything like you to exist at all. You started this thinking about water disappearing, but water was never really the story. The story was always about what depends on it, silently, constantly, including you. Right now, water covers 70% of the planet you live on. Maybe, for the first time, that fact doesn't feel small anymore.